Alright folks, thought we'd just briefly run through some of the issues surrounding the motor coupler. Now what we have here is a coupler that I've manufactured which suits this particular application. No two couplers will probably ever be the same unless it's the exact same motor and the exact same gearbox that you're adapting up. In this case we're using a forklift motor, and there really is no standard whatsoever as to what kind of an output shaft that they have or how they couple the thing up. So if possible, you're best to try to get the fitting that goes onto the shaft from the fork truck. Now, I was lucky in this respect in that I got the female part of the spline that goes on. So this was originally quite a large hub. There's one of those flexi drive things on it. So first thing I did was took an angle grinder, chopped off all the excess material, set it up on the lathe and machined it down to a more usable size. With that done, took a piece of 75mm steel stock, bored it out till it was an interference fit to the size that I had turned the spline coupler down to, and used my trusty 20-ton hydraulic press to put that in there, and it took every ounce of pressure that thing could manifest. A press is something that you very rarely use in a workshop, but when you need it, you absolutely need it. And in this case, it was really the only sensible way to avoid completely making a mess out of this by trying to hammer it in or sweat fit it or something to that effect. Now on the far end here, we have our clutch center, which is a standard clutch disc for the E39. Chopped away all the crap and got it down to this size so that it sits here. As you can probably see, we've got 4 tack welds just holding that in place, and I've gone ahead and I've spun that up on the motor with the gearbox on it, and it runs perfectly true. Now there's a few mistakes that can very easily be made when doing these. This is actually the second coupler that I've made for a car, but I've had a few attempts doing them at intermediate junctures just for really practice. The first mistake that you're likely to make with something like this is to get it absolutely running perfectly on a lathe. Dead nuts on, clocked up the whole thing, put it on the motor and it's doing this. The reason it will do that is that you haven't worked off one of the mating surfaces. In this case, we have the mating surface here, inside size, that goes on to the motor shaft, and we have the inside of our clutch spline here. The thing is that if you chuck this on a lathe on the outside, you have no guarantee whatsoever that outside size is true to the inside mating surface here. So although it will clock up and run happily when it's chucked up from this outside cylinder here, and you put it on the lathe, or sorry, put it on the motor, it's all over the shop. So if possible, you need to chuck from the inside of one side of the mating surface. Now what I tend to do then is I tend to cheat a little bit, and I find that this helps. Even if I did all that and I put it on the motor, I might have a couple of hundredths run out on the thing, and that can cause you problems. So what I tend to do is I drill this hole slightly oversized so that my clutch disc is I can kind of play it around maybe 0.5 millimeter or so. Then what I do, come along, put this on the motor, set up a clock stand. I take a little bit of that PTFE tape that I showed earlier for just that plumber's tape, and I wrap it around the inside size of the clutch spline just to take up the space, and then just hand press fit that in there, get it spinning on the motor, actually on the motor shaft where it's supposed to be, clock it down until I have it absolutely as close to zero run out as I can get some G-clamps, clamp it all up and get a few tack welds. And that's precisely what I've done here, and it seems to have worked out. Now on the E36, what I did was I used 4 M8 bolts drilled and tapped into the coupler, so something like this with a cap screw head on it, going down in there, and with the shoulder here passing through both the clutch spline, the clutch disc, and down into the metal. And the important part of that is that you've got a pin of steel actually taking the side load instead of a threaded portion. A threaded portion would not be a good plan, because these threads will act as stress concentrators when the shear forces come on, and they'll basically ping off and this will spin, and if you don't have a tack limiter on the motor, it'll basically overspeed and explode, which is kind of not really what you're looking for. Now, I could do that here, I might, but I think what I'm going to try with this coupler here, just because of its design, is I'm going to go for a welded option. Now, again, there's some caution needed here. The biggest temptation, if you're going to weld something, is to basically start here and work all the way around it in one pass, be it with a MIG, an arc, a TIG, whatever you happen to be employing. Now, that's going to do two things. The first thing it's going to do is it's going to get everything hot, and you're then going to let it cool. So you have just annealed the hardened steel here and basically softened it, so that again, when the loads come on here, these little teeth will just basically shear away and spin, and bang goes the motor. So that's the first problem. The second problem is welding, by its nature, when the weld pool cools, it tends to pull, it tends to contract and to pull any two surfaces together. In this occasion here, what I had to do is to be very careful, because had I simply gone ahead and ran a bead here and then gone away for even a minute and ran another bead here, this whole plate would have been kicked in that direction. So instead, I had to do 1, 2, 3, 4 small tacks, quick as humanly possible. Once that's done, the plate is held reasonably firm to the coupler body. I haven't put any real heat into this part, and I'm good to go, in theory. How we're going to weld this is going to be a little bit different. I'm going to use a MIG. I'm going to have it on its highest heat setting, and I'm basically going to go 1, 2, 3, 4, stop. stop, turn off the set, walk away. Come back in 20 minutes, half an hour, go 1, 2, 3, 4, stop. Now, what that's doing is, it's letting the stresses go out of the welds. It's letting the heat sink out into the whole part and dissipate into the atmosphere. Absolutely do not attempt any kind of dropping this in a bucket of water or anything of that nature. Again, you're going to start heat treating the metal. Here on the other side of the coupler, I had looked at possibly doing something like coming in through the side here with a grub screw or a bolt or something like that. Thought about it last night, didn't really think it'd be a good plan. I'm going to start weakening, the body of this part, because I'm going to have holes in it, so it's going to have a natural tendency to shear off along where those holes are. Now, I don't know if you can see it on camera, but there's probably about an 8mm gap in here, and it's about 10mm deep. So what we're going to be doing is, again, high heat setting on the MIG, 1, 2, 3, 4, stop. Then we'll come back, again at 90-degree angles, 1, 2, 3, 4, stop. Whereas again, the temptation would be to crank the MIG up and go all the way through that and have a lovely weld, nice bead on it, the whole lot, but I might as well throw that thing in the bin if I did that. So that's enough of me talking. Let's see if we can blow the CCD out of that stupid camera with some welding action. So we're going to need grade power, more power more. Full power on the MIG, which with this set is probably a smidgen over 200 amps. We're running 1mm wire, which is what it seems to be happy with. I'm going to give this thing a little bit of a dart to the old anti-spatter, because we don't want any of those little dots of weld appearing in there to go filing them out and all that, which is quite an unpleasant task. So, let's see what happens. Might need a bit more wire feed on this, but there goes nothing. And stop. So this is going to be a slow process, but that's the nature of what we're doing. And I'm going to need a bit more wire feed on this, alright, no doubt about it. So if I can actually touch this. It's hot, but it's probably looking maybe around, let's say, 60-70 degrees centigrade. And it's already cooling off. I can keep my hand on there for a couple of seconds. So we're not heat treating the metal. Again, around the body of the coupler it's warm, but I can actually handle it. I can actually keep my hand on there practically indefinitely. So that's the nature of doing this without heat distorting the part. And what we'll do is we'll come around to the clutch end and we'll give that a little shot of the old magic juice. We'll turn the wire feed up a notch. Hopefully that's the right direction. I think I'd be smart enough to know which way to turn the damn wire feed after all these years. I'm not that smart though. Yeah, that was the right way, alright. that's it. We're going to turn the plant off and we're going to stop. Ooh, it's got about those pesky capacitors in there. Now, so this in theory is how we do it. And again, I can actually handle the part. It's warm here in the center. I'm sure it's hotter up here. I'm not going to put my hand on that just yet. But there's enough heat sinking here and it's sitting on a metal bench. I can even leave it on the side just to pull the heat out of it and just not have it creating any kind of problems for me. So that's it. We'll come back when that coupler is welded up. And the other trick that you want to look for is we see these little heat distortion marks. I'm not sure if you can, but it actually means that we're penetrating into the steel. You can see them up here as well. We've got heat distortion marks going down into the steel here. So yeah, a bit of luck and a prevailing wind. I think this will work out. So come back when the coupler is done and we'll be looking at fitting it onto the motor, and we'll go through locating the bell housing holes for the old geary box. So we're over here at the minute. Let's see if we can do a bit of panning action. Can we do some panning action? Yeah, the old Cecil B. DeMille scenario. So as you can probably see here, we've got our adapter plate on as we had before. Put our motor shaft, and we'll be locating the holes. Once the coupler is fully down onto the shaft and it's spinning, we'll be dropping the gearbox on there and going ahead with our what you call them, locating punches. Locate the holes, mark the necessary size, drill, tap, back on, bolt up, check everything's happy. Go around with a marker, and then it's fun and games with either the jigsaw, the milling machine, or a combination of the two. Alrighty folks, we're back after the welding session. Worked out very well, welded up on both sides quite nicely, and spun it on the motor, spinning through. So last piece of the puzzle, went ahead there and drilled and tapped a hole 8mm just in the side for a little grub screw, and that little guy will go in there and just pinch onto the shaft on the motor just in case. Probably not really needed, but better safe than sorry. And so that's our coupler. So going to get it on the motor, and we'll do a little spin with the gearbox, and we'll go through locating the bell housing holes. Alrighty folks, you can see now that motion, just running on a 12-volt battery, and I might just be able to get us in here. Have a look at our coupler, running away happy as a clam. Give it a little coating of paint there just to keep the atmospherics off it. Let's try and get next to a bit of light in here. Hang on a sec. The old camcorder light isn't exactly magic. There we go. So there's no oil in the gearbox at the minute, so apart from that, commutator blasting away. So that's it. Next part of the plan, we're just locating the Just locating the holes for the bell housing. Sure is good to see that. This part is, to me anyway, almost as good as the first test drive. Just to see that drive flange there spinning without an engine attached to it is well, that's what it's all about for me anyway. If my battery's going a bit low, I'm going to disconnect it. And right, so that's it. So the procedure really to line this up is pretty straightforward with these BMW gearboxes. As you can hopefully see down there, I've got the lifting eye screwed into the motor frame. Now that's basically right at the top of the motor. So what you want to do basically is just by eye line up this is the shifter mechanism, and that's right down the middle of the gearbox. Sorry, just been eating too much turkey. You want to line this guy up right down the center line of the gearbox so that it basically matches with the lifting eye, and that gives you the center line for where you want to position the gearbox in terms of a twist. So the next thing we'll be doing, be using our punches. These are locating punches. Cheap to buy, but very useful. Go in 0.5 millimeter sizes, I believe, from about 1 millimeter up to, I think, 12 or 13. I think that's a 12, that's 12 and a half actually. So you want to do is you want to pick the punch that gives you a nice slip fit into whichever the holes on the bell housing. Come along with your trusty persuader, give it a tap, and if we take that out, I don't know if we'll be able to see with this marvellous camera, probably won't, but there is a dot directly in there in the exact centre of that hole, and it's basically straightforward then to just go around the various holes, choosing the punch that best fits each one, dotting the holes, coming back, taking the gearbox off, taking the plate off the motor, putting it on the drill press, drill them out, tap them, back on, bolt it up, make sure it's spinning happy. Once that's done, we'll do our outline with a marker, and then it's just jigsaw and milling machine or some combination of the two. And so we'll come back. I'll come back when I have that plate drilled up, tapped, and we'll give it one last run, and then we'll take it all. We'll take the plate off and start cutting the thing. So back soon. Alrighty, so we've gone around with our locating punches, located the major holes. We have 4 12s, 2 10s and 2 8s. So that's more than enough bolt action to hold the gearbox on. So the next stage, still eating too much Christmas food. Is to basically take off the gearbox. So we're going to go ahead and do that. And once we have the gearbox off, we'll just make sure that we've all our try and take this off cleanly in one go. There we are. And what we want to do now is, I've got a cordless drill here with a little centre drill in it. I'm going to go around all of my dots, and just give them a little dart to the centre drill. And just make sure that there's no tendency for the drill in the drill press to slip off. Hold centre. So I have to say, I find those transfer punches marvellous. I think they're about 20 quid for the set, but more than paid for themselves for a number of different jobs. Also, good news here is that only one of the bell housing holes comes even slightly close to one of the motor mounting holes, which is this one here. Unfortunately, that's I don't know, I should say that's a 10, so I think we'll actually be okay with that. So that's the plate, so we're going to go ahead now and take that plate off. We're going to start off and drill all the holes 5mm, and then we'll go to 7mm for the 2/8, 8.5 for the 10s, and I think it's 10.5 for the 12s. So we get that done. We'll get them tapped. It's just basic hand tap operations. There's no need for me to be showing people how to do that. I think it's just boring. It's just lots of twisting. So we'll come back when we have the holes tapped. We'll get the plate back on the motor, and we'll get that gearbox bolted in, and we're getting down to the final stages, folks. Alrighty, we're back again. Plate's back on, holes drilled and tapped, and gearbox is bolted on. I don't have all of the bolts in at the minute, but enough just to make sure we're all happy. And there's absolutely no trace of vibration out of that gearbox whatsoever. It's running away there at 12 volts in gear, and spinning away merrily. So I've gone around the gearbox with a marker, just gone around the profile of it. So next task will be to, as we've said, either jigsaw or mill or a combination of the two, get that out of there, and that'll be the adapter plate. So we're closing in on it. Some new stuff gone on the coupler on that today, so there we have it. So we'll come back in the next instalment and we'll hopefully have the adapter plate cut down to size. But I have to say, so far, really can't complain. It's gone fairly smoothly, and we'll get this puppy into the car as soon as there's a few more things done with it, and see if it'll move the wheels. I have a suspicion it will. So that's it. We'll be back soon, as I say, when the plate's cut down. We'll start going through things like the RPM sensor and cooling ducting and all that stuff. Have to see about getting one of those excess turbos blowers from Jack. And yeah, that's about it. See you all soon.